So the next problem I want to do is number 16. A random survey of autos parked in the student lot and staff lot at a large university are classified by the brands below. And so we're trying to see if there's a difference between the national origins of cars driven by students and staff. And so the question is it the test of independence or homogeneity? Which it is the second one, okay? Because we're trying to see if there's a difference. So the first step is to write your hypothesis. Your hypothesis is that there is no difference between the cars. There's no difference. And so the null hypothesis is going to be that there is a difference between the car and the type of driver, okay? So again, the null is that the distribution of car origin is the same for students and staff, and the alternative hypothesis is that the distribution of car origin is different for student and staff. So the first says it's the same, the second one says it's different, okay? When it says check the necessary conditions, so we have to check our conditions, and the first condition is whether or not it's counted data, and yes, these are all counts. The second one is whether or not it's random, and it did say that it was survey randomly. It says a random survey. And then the last one is the expected self-frequency has to be at least 5, and that's what we're going to have to figure out, and we're going to have to see if those are all at least 5. And so the expected self-frequency, I think, is the place that's going to get you a little stuck. So what I've done is I've made a table, and I've put these numbers in here, okay? What we need to do, though, now is we need to know what these totals are, okay? So if you haven't written this down, my suggestion is go ahead and pause the video and write it down so it kind of makes sense of what's going on, okay? Okay, so what I had to do was I had to create another table because I have to find the observed and expected for students and staff. So now I have a table that kind of split it in half so that I can see. So I know the observed. I know that the observed for the students is 107, 33, 55, and then 105, 12, and 47. The question is, how do we get the expected? And so what happens is I have to look at my total numbers here, right? I know that I have a total of 359. And so when I look at my American-made cars, I'm expecting 212 out of 359. That's my expecting percent. For European cars, I'm expecting to have 45 out of 359. And then for my Asian cars, I'm expecting to have 102 out of 359. And so you can find out what those percents are, or you can leave those as fractions. Okay? Okay, so I went ahead and calculated those as the percent. So 59% are American, 12% are European, and 28% are Asian. And so now I need to figure out what's expected. Well, to find out what expected, I know I have 195 students. So to find my expected, I do my expected percent times my 195. I do my expected percent times my 195. And again, my expected percent times 195. And over here, instead of the 195, I'm going to be multiplying by 164 because I have 164 staff. Oops, 125 times 164, and 0.284 times 164. So the first thing we had to do, again, is we had to figure out what we were expected. And you find the expected by finding out the breakdown of the different types of cars. Okay, and then we found out that gave us our expected percent, and then we found out how many our actual count was by multiplying it by the number of students we had and by the number of staff we had. Okay, so now what I need to do is I just need to run a test on it, okay? And so what happens is I can't put these in L1, L2, L3, and L4. Remember that our observed go in L1, so this is an L1 and this is an L1, and our expected goes in L2. So I'm kind of collapsing everything. Oops, can't see that. I'm kind of collapsing everything into two lists. So take the time now to put all those in your L1s, L1, and then in your L2s. Okay, so I have all my numbers in L1 and L2. And so now what I'm going to do is I'm going to do my chi-square goodness of fit, or my chi-square goodness of fit test, even though I'm testing the homogeneity, whatever it is. I got to do this part. So calc, test, go here, and this is going to give us our stuff. Okay, so L1 and L2. Now we need to talk about the degrees of freedom. Because we have two different categories, what happens here is the degrees of freedom for the cars is 3 minus 1, so that's 2. And the degrees of freedom for the staff and students is 2 minus 1, which is 1. What you do with these numbers is you multiply them. And so, oops, you can't see that, but our degrees of freedom is 2. So once we find all our expected and plug everything else, everything in, the last thing we had to do was find our degrees of freedom, which was 2. We calculate, and so that's a very small p-value of 0.02. And so we would reject the null that there's not a difference, that they're the same. And so we have evidence to show that there is a difference between the type of cars that staff and students drive. So if you have questions, make sure you watch it again. We will definitely practice some of this tomorrow because these can be tricky. Thank you.